There, hope you're fine. This is Philip explaining. So in this video I'm going to discuss logic gates under digital electronics. So what's a logic gate? A logic gate is a digital device that is used to perform a logic operation. Let's see. So as I have said earlier on that a logic gate is a digital device used to perform the logic operation. So in this video we are going to look at different types of logic gates. We have I can say types of logic gates. I can say you have OR gate, NOR gate. You have an AND gate, and we have a NAND gate. So we shall discuss these four here. We have other types of gates, but in this video we are going to look at these four: OR gate, NOR gate, AND gate, and a NAND gate. So let's start with an OR gate. So an OR gate is an electronic circuit that gives a high output 1. Remember, high output is 1 and low output is 0. So an OR gate is an electronic circuit that gives a high output 1 if one or more of its inputs are high. A plus, this plus sign, a plus is used to show the OR operation. So this is a symbol for OR gate. OR gate. It has two inputs, X and Y, and an output Z. So, and I have said that a plus is used to show the OR operation. So X plus Y gives us Z. These two inputs, the summation of these inputs gives us the output Z. And the truth table now, truth table for an OR gate, remember it has two inputs. So to determine the number of entries, remember the number of entries is given by 2 raised power n, where n is the number of inputs. N is the number of inputs. So for this OR gate, it has two inputs, X and Y. So the number of entries will be 2 raised power 2, which is 4 entries. Hope you understand. So the truth table will be given as X, Y, Z, we have when X is 0, Y is 0, when X is 0, Y is 1, when X is 1, Y is 0, when X is 1, Y is 1. Are we there? So remember I have said that OR gate just get the summation. The outputs given by the summation of the inputs. So 0 plus 0 gives us 0. 0 plus 1 gives us 1. 1 plus 0 is 1. 1 plus 1 is 1. Are we there? This means that when An OR gate gives a high output only if one or more of its inputs are high. I've said when it is 0, 0 denotes a low, but 1 denotes a high. Are you there? You can see 0, 0 gives low, 0, 1, so you have 1. One of the input is 1, is high, so it gives high. The same. Are we there? So let's look at the next one, AND gate. AND gate. AND gate. Hope you understand. So an AND gate, it is an electronic circuit that gives a high output. I've said high output is denoted by 1 only if all its inputs are high. Now for AND gate gives high output only if all of its inputs are high, and a dot is used to denote this. This is for OR, it's a plus. For AND gate, it's a dot. Dot is used to denote it, the AND operation. And you have to bear in mind that this dot is sometimes omitted. For example, as we shall see, let's start with or by showing or drawing or sketching the symbol for AND gate. This is the symbol for AND gate. This is the output Z. Have the two inputs X and Y. The truth table. You have two inputs, so the number of entries will be 2 raised to power 2, since you have the two inputs, which gives us 4 entries. So let's look at the truth table. X, Y as the inputs and the output Z. So since you have the two entries, you can have low 0 0, 0 1, 1 0, and 1 1. So we have said that a dot. This dot is used to show the AND operation, and this dot is a multiplication. Are you there? Dot is a multiplication. So 0 times 0 gives us what? 0. 0 times 1 is 0. 1 times 0 is 1, and 1 times 1 is 1. 1 times 0 is 0, sorry. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. Then 1 times 1 is 1. So you can see that for us to get a high output in when you are dealing with the AND gate, we must have all the inputs. All the inputs must be high. All the inputs must be high. Are we there? 1 1, as you can see. Hope you understand. Without wasting time, let's go. I will move to the next logic gate, the NOR gate. NOR gate. So for this OR gate, this is just a NOT or OR gate. I'm saying it's a NOT or OR, not. I write it here, NOT or OR gate, which is equals to an OR gate. This OR gate followed by a NOT gate, I mean, in this video, I have not looked at a NOT gate. I have not looked at it, but we shall look at it maybe in the next video, God willing. So I'm saying that an OR gate is a not OR gate, which is equal to an OR gate followed by a NOT gate. The inputs of all NOR gates are low if any of the inputs are high, and the symbol is an OR gate with a small circle on the output. Then that circle represents inversion. The circle represents inversion. Let's draw or sketch a symbol so that you can see what I'm trying to tell you or I'm trying to explain. So this is the symbol for an OR gate. Symbol for an OR gate. It's just an OR gate. Then it has a circle here for inversion. Circle for inversion. So it has the two inputs, X, Y, and an output Z. So the truth table, see the number of entries. It's 2 raised to power 2. Since it has two inputs, gives us four entries. So X plus Y gives us Z, but we invert. For this, I've forgotten to write it here. This is X dot Y gives us Z, and then for this one, for an OR gate, is X plus Y gives us Z. So you can see that the difference between this and this is just this bar for inversion. Let's see how this inversion works, or how it is solved, or how it is written. So you have X and Y as the inputs, Z as an output. You have 4 entries. You can have 0, 0, 0, 1, 1, 0, and 1, 1, 1. Are we there? So 0 plus 0 is 0. If we now invert, remember when you're dealing with this logic gate, when it's not 0, it's 1. Are we there? When it's not 0, it's 1. When it's not 1, it's 0. So 0 plus 0 is 0. When you invert, we get 1. 0 plus 1 is 1. Inversion, 0. Are you there? 1 plus 0 is 1. Inversion, 0. Then 1 plus 1 is 1. Inversion, 0. So you can see that the result for NOR gate is just the inversion of an OR gate. 0 have 1 here, 1 0, then 1 0, 1 0. Hope you understand. So let's move to the next one, a NAND gate. NAND gate. So a NAND gate, this is just a not AND gate. As you have said that an OR gate is just a not OR gate. Remember, you have just started N here, or N or R, so OR gate. So for NAND gate, are you seeing this N? You have just placed it here. So a NAND gate is a not AND gate, which is equal to an AND gate followed by a NOT gate. The outputs of all NAND gates are high if any of the inputs are low. And the symbol is an AND gate with a small circle on the output. The small circle represents inversion, just the same way. It means that the result that you have gotten here will just invert. If here is 0 for AND gate, it will be 1, 1, 1, then 0. Are we there? Let's see. Let's start by the symbol. Just an AND gate. AND gate. Are you getting what I'm saying? Are you getting the connection? AND gate and NAND gate. OR gate and then NOR gate. So it's just an AND gate, but you have a circle here for inversion on the output Z. Have the two inputs, X and y. Truth table. Since we have the two inputs, the number of entries will be 2 raised to power 2, which gives us 4 entries. 4 entries. So we have x dot y, but we invert. X dot y, no inversion for AND gate, but an AND gate we inverse. We invert the answer, gives us z. Are we there? So we have x, y as the inputs, then output z. Have 0 0, 0 1, 1 0, and 1 1. So I have said for AND gate that this dot is a multiplication sign. Are you getting what I'm saying? And sometimes it can be omitted. Sometimes it can be omitted. So 0 times 0, 0 times 0 is 0. The inverse 1. Inversion is 1. 1 times 0, or 0 times 1 is 0. The inversion 1. 1 times 0 is 0. The inversion 1. 1 times 1 is 1. The inversion 0. Hope you understand. And at that point I can say that we are through with the 4 types that I have promised to, that I'm going to discuss in this video: OR gate, OR gate, AND gate, and NAND gate. We are through with this, but I have promised you also that I'm going to add you another one, a NOT gate, because I've been mentioning NOT gates. For example, under NOR gate and a NAND gate, we have said that, for example, for a NAND gate, that a NAND gate is a NOT AND gate, a NOT AND gate. So I have not looked at this, and I have said that NOR gate is a NOT OR. So let's look at a NOT gate. A NOT gate. NOT gate. So a NOT gate is an electrical circuit that produces an inverted version of the input at its output. Produces an inverted version of the input at the output. For example, if it is 0 as the input, it gives output as 1. If the input is 1, it gives an output as 0. So it's also known as an inverter. The NOT gate is also known as an inverter. Inverter. I can say inverter. If the input variable is x and the output is known as not x, this is also shown as x prime, or x with the bar over the top. So then the not x as the inverted output of the input x, I'm saying that the not x as the output of the input x, can also be represented or shown as x prime, or x with the bar over the top, as shown at the outputs, as you can see here. So this is the symbol for a NOT gate. This is the input x and then output y, and this is the circle for inversion. So the Boolean equation for a NOT gate, y is equals to the inverse of x. Are you getting what I'm saying? I've said that when the input is x, then the output for a NOT gate or the NOT gate will produce an output with a NOT X as the output, or X with the bar, or X prime. I see. And here in the symbol I have said that the input is X, so the output is Y. This Y can also be X with the bar over it, or X prime. So one output, remember it has one output, so the number of entries will be one output, one input, sorry, it's one input X alone, as you can see. I have said that the number of entries is given by 2 raised power n, where n is the number of inputs. So when the input is 1, the number of entries will be 2 raised power 1, which gives us 2 entries. 2 entries. And now the truth table for a NOT gate. X, Y. So when X is 0, Y will be 1, because just the inverse. And I have said the inverse of 0 when dealing with these logic gates, with these logic gates, the inverse of 0 is 1, and the inverse of 1 is 0. So when X is 0, then this NOT gate will produce an output Y, which will be 1. Then when X is 1, the inverse will be 0. So hope up to that point, hope you understand, and I can say I'm through with that. I'm through with that. So thank you for watching. Thank you so much. Hope you have enjoyed, and you have learned something. If you have any query or any suggestion, just put it or write it or type it under the comment section. And if you are new to my channel, or you are seeing me or hearing me for the first time, or you are new to my channel, kindly subscribe, and don't forget to hit the bell notification, so that for the moment I'll be uploading a new video, will be getting notified. Thank you so much. Till next time. Bye bye.